Okay, let's go on to the next slide, please. I think most of you know that MROs has a dual purpose mission, both for science as well as for programmatic support. Regard to science, based upon the senior review proposal submitted last year and approved, there are 16 investigations that address 4 goal areas, things like environmental transition, habitability on ancient Mars, more recent geologic times, Amazonian ices, and climate through looking at volcanic surfaces and such. And then modern Mars. This is a dynamic planet. It's changing today. Understand important, and being able to extrapolate those back into the past with confidence really depends upon us being able to do that and to see and compare with that for the future.
Sorry, Rich, can you speak up just a little bit?
Yeah, just a moment. I think my phone is dying, so I may have to switch here. And programmatically, MRO has been looking at certifying and characterizing landing sites as well as conducting relay. One of the more interesting aspects of this is the fact that we've been looking at the areas outside of Jezero Crater where M2020 might be going and ensuring that there are places where the retrieval lander will be able to set down within range of either the fetch rover or 2020's ability to bring samples back to that lander for return to Earth. Next slide, please. Here's some of the orbiter highlights and such, and I'm going to let you read through most of this as we go through here. But some of the areas that we've been focusing on, of course, are the distribution of ice across the planet and its exposures, sometimes in remarkable things like 100-meter tall cliffs exposed in the high latitudes of the planet and such. As we have been looking at and proceeding with our EM5 proposal and activities, we started some new things like thermal ice mapping at higher spatial resolution than you can get from the gamma ray and neutron spectrometers kind of footprints, trying to interpret the thermal inertia revealed in the temperatures as a way of looking for shallow ice. Atmospheric monitoring and surface monitoring following the 2018 Planet Encircling Dust event has also been a prime activity. There was an interesting mid-spring event that was a dust storm large enough to affect the middle atmosphere, which is a little unusual for that season, which is generally relatively clear of those kinds of events. Let's go on to the next slide. So taking a look at the some of the things in the upper right, the so-called swim activities, subsurface water ice mapping in mid-latitudes, that is continuing on. Looking at what high-rise seas and the layered terrains of the polar deposits and such, Pat Becerra's work on matching the periodicities and that stratigraphy is revealed by high-rise to the orbital climate patterns. It gives you a chance to understand the periodicities and the rates at which various terrains have been built in the South Polar region and such. In the lower right, taking a look again at the dust storm activities. As Bruce mentioned, water vapor is brought into the middle atmosphere. Dust is brought to very high altitudes and must be to be sustained there for any length of time. The convective activity of the vertical velocities must be very large. And of course, MRO, if it's long record, can now look at the variation of how the dust in the atmosphere affects the temperatures and structure of the atmosphere in various Mars years. Over on the lower left, we're continuing to look for these exposures of ice, and a number of new icy scarps have been identified. Colin Dundas has been working on this. And also there was the observation that there seem to be many more of the recurring slope lineae after the planet encircling dust event. Whether that's an observational effect, that is, the dust provided bright background against which you might see these things, or a causal effect, is still being studied. If we can go on to the next, before we do, the next time step here, I wanted to show you just an example of some of the processing of past data and such as we're taking a look at how we can improve these things. These two scenes, on the left is the old processing and on the right is the new processing, which was actually developed to look more at the survey data in the map tile products that CRISM produces and such. You can see that you can remove more of the atmospheric effect, fill in some of the data glitches and such that otherwise would occur. This has been a major effort by the team and promises to give us a much improved higher level data product from the investigation. Next one, please. Next time step. So what's the problem? You've already heard a bit of this, and you're going to hear more. This is a plot of the MRO science budget and how it will fare under the President's budget for FY21 through 25. In FY21, there's a $2 million drop that essentially takes MRO down to its science floor. That's going to necessitate closing out a couple of the investigations eventually and reducing the amount of observations, targeting by maybe half, just because you'll be observing in fewer cycles, planning and such. It will also impact the ability to produce special data products like DTMs and to work on new ones. And it will also impact the ability to coordinate with other missions, which has been an important part of what MRO proposed during this period. Because there's another $2 million drop over the subsequent years, as shown by the President's budget, we will not be able just to cut across the board, but we'll have to selectively remove investigations just because the funding otherwise will be too low to accomplish things for everyone. So that's fairly
2 more minutes, Rich.
Yep. Project's asking for more. Go to the next step. Just to give you a graphic illustration of this, these are the 16 investigations that we've been proceeding on this fiscal year as part of the EM5 proposal. And as you can see, they stretch through the 4 goal areas and such. You can take a look at these. The next time step shows you which of these we can make progress on under that reduced budget and which ones are going to be difficult if we'll essentially have to stop activity after this year in those areas. Those are the ones marked red. Green ones are the ones we'll give emphasis to and fully carry out. The others will be impacted. Final slide. Next one, please. So the MRO spacecraft is healthy, and you might ask how I can say that. Well, after I prepared this chart and submitted it, MRO went into safe mode. It does that occasionally, about once every 2 years or so. The spacecraft seems to be very healthy. In fact, the team is in the process of bringing it out of safe mode even as we speak today. And we'll probably resume relay and science observations early next week. All the instruments have technical capabilities to achieve the mission science and the programmatic objectives that have been proposed. And it's just a matter of how much we can do and such. I might remind you that that proposal and the 16 activities were judged to be an excellent plan in the Planetary Mission Senior Review. So we're ready to go. The project has proposed an overguide to be able to provide the full and execute the full plan as we go forward. And we think that's what the community would like us to do to address compelling questions about Mars. So there's a very quick summary and status for MRO. Question.
Thank you very much, Rich. To stay on time, we're going to move on to Ashwin's talk, but I see that there are a couple of questions for you, so hopefully you can address them in the chat window.